Good morning, guys. In today's class, we are going to graphically analyze speed, velocity, and acceleration. What are the key concepts? Now, we are going to talk about the distance time graph and the speed time graph. And we are going to understand that the gradient of the distance time graph is the speed, and the gradient of the speed time graph is the acceleration. Area under the speed time graph is the distance traveled. So let us plot a graph and let's try to analyze the graph. So let us say we have on the x-axis the time and on the y-axis we have the distance. So this is a distance time graph. We know that we have the independent variable, which is the time, along the x-axis, and we do have the dependent variable, which is the distance, along the y-axis. So how are we going to calculate speed from this graph? Well, the speed is actually distance over time. And you see, if you are going to calculate the slope of the graph, you are going to calculate distance over time, because slope is technically rise over run. This is the rise, and you see this is the run. So rise is the change in the distance, and the run is the change in the time. So if you take rise over run, we are going to calculate the speed. So let's see what is the rise. So let us say we have 600 and this is going to be 1200. So this is going to be 600. 1200 minus 600, which is 600. And then we have the run, which is equal to, let's say from here we have 3 hours and here we have 6 hours, so the run is going to be 3 hours. So when we calculate the rise over run, we are going to get 600 over 3, which is 200 kilometers per hour. So you see, the slope of the distance time graph actually gives you the speed. Now you could pause the video and try to analyze the speed at different points. So let us say we try to analyze the speed from time 1 to 2 hour, and we try to calculate what is the slope. So you see the rise is 1 kilometers and the run is 1 kilometer as well, and the speed is the rise over run, which is the slope, which is 1 over 1, which is equal to 1. So the speed from this particular point to this is actually 1 kilometer per hour. Now let's talk about this part, the horizontal part. You see, here the rise is 0, although we do have a run from 3 to 4, but the rise is 0. So since the rise is 0, 0 divided by the run, which gives you 0, hence the speed is 0. And that does make sense, because you see from 3 to 5 hours, if you start from 3 and till 5 hours, you see even though there is an increase in time, the distance remains the same. So technically it means that the object hasn't been moving, so the speed is actually 0, because even after 2 hours time interval, the distance covered is the same. Now let us say we try to calculate the speed from 5 to 7. Now we could calculate the slope. So let's say we take 2 points, we try to find what is the rise. So the rise is going to be from 4 to 6, which is 2, and the run is going to be, I think, 5.5 to 6.5, which is 1. So technically the rise over run, that is going to be 2 kilometers an hour. So here we have the answers. Okay. Now if the object is traveling only in one direction, the distance time graph is also called as the displacement time graph, because displacement is a vector quantity and here we are specifying a direction. Now steeper the line, the greater would be the speed. This is because if the line is steeper, it means that the slope is more. So a steeper line means greater the speed. So let us analyze these graphs. You see here the car is at rest. So obviously when the time is 0, the distance is 25. Even after 1, 2, 3, 4, 5 seconds, the distance remains the same. So you could plot a graph something like this, and this is it has got a zero slope, so obviously the speed is zero. Now you could actually calculate for part B, you could actually calculate the speed by calculating the slope. So let's say your rise is going to be from this point to this point, which is actually 50, and the run is 0 to 5, which is 5. So 50 over 5, which gives you 10. So 10 meter per second. Now here the car is moving with a non-uniform acceleration. And if you closely analyze, you will realize that for every time interval of 1 second, the distance is increasing. So you see from 0 to 1, it is 10, then from 1 to 2, the increase is 15. So if you have a curve something like this, you realize that with with the increase in time, for the same interval increase in time, the increase in distance is greater. So obviously the car is accelerating. Here you see the car is deaccelerating because as the time increases, the distance decreases. For example, let's say for 1 to 2, the increase in the distance is 25, but for 2 to 3, the increase is just 20. So technically the car is deaccelerating, and you have a curve something like this. Now let's talk a bit about speed time graph. Now speed time graph may look very similar to distance time graph, but the information they provide is completely different. Because let's talk about speed time graph. Now if there is a line horizontal and parallel to the x-axis, in case of a distance time graph, it means that the object's speed is zero. But let's say when we have the same situation in the speed time graph, it means that the object is moving with a constant speed, because you see as the time is increasing, the speed is remaining the same. So even for 1, 2, 3, 4, 5 seconds, the speed is pretty much 10 meter per second. So a horizontal straight line parallel to the x-axis or parallel to the time axis in a speed time graph means the object is moving with a constant speed. Now, how about a graph like this, part B? Sorry, this is part C. So you have time along the x-axis and the speed along the y-axis. Now, you could actually calculate the slope of this graph, and you see if I calculate the slope of this graph, the rise is going to be 20, and the run is going to be 5. So 20 over 5, which gives you 4. But what is that 4? Because the 4 is the rise over run, but is change in speed over change in time, and that is actually acceleration. Since the speed is in one direction, so this could be also called as velocity. So say this is actually change in velocity, because from this point to this point, you see the speed is increasing, and that is 20 divided by 5. So there's a change in speed with respect to time, and that is acceleration. So the acceleration is 4 meter per second squared. Now here, if you look at this graph, the initially at time 0, the speed is 20 meter per second. But you see as the time is increasing, the speed is decreasing, because from 0 to 1, the speed has gone down to 16. From 20, it is now 16. From 1 to 2, it has gone down from 16 to 12. So you have a graph something like this. So technically, if you are asked to calculate the acceleration, again you calculate the rise over run, but in this case it's a decrease. So obviously it is going to be negative 20, negative 20 divided by 5, which gives you negative 4 meter per second squared, and this is called deceleration. Now again, in this case, you see if you have a curve like this, you realize that as the time is increasing, the speed is increasing. For 0 to 1, it was just 2, and for 1 to 2, it is from 2 to 5. So the speed is increasing. So you got a curve like this. It means that the acceleration increases. And here we plot a curve where we have a decrease in the acceleration. So you see, as the time is increasing, the speed at 0 was 0, at 1 was 6, at 2 was 11. So for one interval increase in time, the speed is 6 in the first case. Again, for one interval increase in time, the speed is 5. So technically the speed is decreasing. So you could plot a graph of acceleration decreasing in this form. Now let's do an example. We have a graph like this, and we want to calculate what is the maximum speed of the lift, for how many seconds does the lift move. uh, this diagram is for a graph, speed time graph of a moving lift. And then how much speed does the lift gain in first 10 seconds, what is the acceleration, what is the deceleration of the lift in last 5 seconds. So let's talk about first part. What is the maximum speed of the lift? So you see, if you look at the graph, it it increases from 0 until it reaches to 10. At 10 it becomes constant, and then again it goes down. So the maximum speed is going to be 10 meter per second. Now for how many seconds did the lift move? Now technically you see, from 0 to 10 the lift is moving. And then let's talk about here from 10 to 15, sorry, from 10 to 20. Although the line is parallel to the x-axis, but still you see there, for each and every point it corresponds a speed of 10 meter per second. So technically the lift is moving here as well. And then again from this point to this point, you see the lift is moving, because as the time is increasing the speed is decreasing. So for the entire time period of 0 to 25 seconds, the lift is moving. So the lift moves for 25 seconds. Now, how much speed does the lift gain in first 10 seconds? So for the first 10 seconds, from 0 to 10, the lift gains in speed of uh, this is 10, and this is divided by 10. So because they're asking you how much speed does the lift gain in first 10 seconds. So in first 10 seconds it is going to be, the speed is 10 but the time is also 10. So technically when you have 10 over 10, that gives you 1 meter per second squared. So technically they are asking you what is the acceleration. So acceleration is rise over run. So when you calculate the rise over run, you calculate the acceleration. Now the second part, the last part rather, what is the deceleration of the lift in last 5 seconds. So when we talk about the last 5 seconds, you see the lift's velocity at 20th second was 10, but at 25 second it is 0. So acceleration is the slope, which is the rise over run. Now the rise here, there is a negative rise, so that gives you negative 10 over 5. So negative 10 over 5, which is negative 2 meter per second squared. You can interpret another way as well, because acceleration is final velocity minus the initial velocity divided by time. So if you analyze that way, the final velocity is 25. Here for this particular part from 20 to 25, the final velocity is 25. The final velocity is 0. Sorry, the final velocity is 0. The initial velocity is 10. So 0 minus 10 divided by the time, which is 25 minus 20, and that gives you minus 10 over 5, which is negative 2 meter per second squared. Pause the video and try to do this problem yourself. I have given the answers, and double check your understanding with those answers. Now we need to talk a bit about area under the speed time graph. Now let's say you have a speed time graph, and the area under the speed time graph actually gives the distance traveled. So let us say if you have the speed time graph, so if I calculate the area of this rectangle, I will get the distance traveled by the car. So let's say here we have The area of the rectangle is length times width. Here the length is 5 and the width is 10. So the area is going to be 5 times, sorry, the length is 5 and the width is 20. So 5 times 20, which is 100 meters. Let us talk about this one. Now, figure 2.17 shows the speed time graph of a car traveling along a straight road. What is the distance traveled in first 10 seconds? So let's say from 0 to 10, 0 to 10, you get a triangle. So in order to calculate the distance traveled, you'll have to calculate the area of this triangle. So area of the triangle is going to be base times height divided by 2. So the base is going to be 10, the height is going to be 30. So 10 times 30 divided by 2, which gives you 150 meters. Now, what is the total distance traveled? So when you are asked to calculate the total distance traveled, you are asked to divide the entire figure into geometric shapes. So let us say you have a triangle like OAP, and then you have a PABQP, a rectangle, and then you have a triangle QBC. So what you need to do is to calculate the area of all three figures and add them to calculate the total distance traveled. I mean, some of you might consider this as a trapezium and you might calculate the area of a trapezium. Well, either way, this is perfectly fine. So if you were to do it by a triangle, you need to calculate the area of this triangle, you need to calculate the area of this rectangle, and then you need to calculate the area of this triangle. Add all three and you get the distance traveled. Here I have considered this as a trapezium and I have used the formula for trapezium, which is half times the sum of the parallel sides. So you see the parallel sides from A to B, this is going to be 10 and 30, so this is going to be 20, and this is going to be O to C, which is going to be 42, which is 42. So half times sum of the parallel sides, which is 20 plus 42, multiplied by the distance between the parallel sides, which is 30, and you solve it and you get 930 meters. Now, what was the time taken for the whole journey? So you see the time taken for the whole journey is like you try to read the graph. It starts from 0 and it ends at 42. So the time taken for the whole journey is 42 seconds. Now, what is the average speed for the whole journey? So average speed is the total distance divided by the total time. So you need to calculate the total distance, which we already calculated as 930 meters, divided by the total time taken, which is 42, and you get 22.1 meter per second. Perfect. About free fall, we are going to talk in the next video. So far, we have covered the speed, velocity, and time graphs. Try to analyze those graphs and practice some more questions.